We welcome you all to the lecture series on electric and hybrid vehicle technologies presented from the Center of Excellence for Hybrid and Electric Vehicle, KPR Institute of Engineering and Technology, Coimbatore. Today we shall begin by understanding the reason for pivoting away from our well-defined IC engine vehicles towards the electric and hybrid vehicles. We will see the reasons, historical developments, emission norms, and its advancement. After understanding the background, we'll begin our understanding with electric vehicles, followed by hybrid vehicles, and this we'll study series hybrid vehicle, parallel hybrid vehicle, and series parallel hybrid vehicle. We'll also review fuel cell vehicles, post that we'll study energy storages or energy storage devices, all about energy storage devices, and say as a bonus we'll refer regenerative, I hope this is okay. So this is how we'll move according in our entire course series. So starting with our first topic of interest, we need to be very clear in associating ourselves with why the world is moving towards EV and HVs instead of our traditional combustion engine systems. We'll start with reason number 1. We have air pollution. So what happens, we get a fuel. What happens in IC engines, we use fuel which is made up of hydrocarbons, basically hydrogen and carbon in various forms. When it reacts with air, that will have carbon, oxygen, nitrogen in various combinations and other elements. We expect upon burning in this term, what happens is this reaction we need them to combust. So burning is nothing but upon the process of combustion, which is reaction between fuel and the air, which will release, we'll get major amount of heat. Q is a symbol of heat, majorly used in mechanical engineering books, thermodynamics. So I'll write it down here. This is heat and pressure we'll get, which is then converted into the work that you see, because of which the vehicle starts to propel forward. With this heat, we also get other combustion products. Now if you can see, if we look at this, if we have majority of the component, we have nitrogen and oxygen in the air. So if hydrogen reacts with oxygen, we should get water, because water is H2O. We should get carbon dioxide, CO2, and maybe some amount of nitrogen dioxide. Okay, understandable, but very little. This is an ideal case. That does not actually happen. And the problem is, the formation of nitrogen dioxide should also not exist in combustion. But due to high temperature of combustion that happens under IC engines, it makes it a favorable condition that the formation of forms of nitrogen oxide occurs as a product of combustion. So what we actually get, instead of, let me move this here for reference. What we actually get is nitrogen oxides, number one, and we get carbon monoxide, that's number two. We get unburnt hydrocarbons. Not necessary that everything that comes inside will be burning all the time properly. And finally, we have some other pollutants in smaller but still harmful state. In nitrogen oxide, so let's review each of them one by one. We'll do a very small tick of all of them. So what happens is, when nitrogen combines with the oxygen in the air at very high temperature, it gives us, one form is, we get NO, that is nitric oxide. Second, we also get NO2, that is nitric dioxide, and some small amount of N2O, that is nitrous oxide. The problem what happens is, this quantity of NO, I'll write it here in a separate form. This NO, once released in the atmosphere, comes in contact with good quality oxygen and forms N2O. Oh, sorry, NO2. We are not balancing the equation right now, but that's what we get. Now this nitrogen dioxide, when it gets exposed, we'll use harmful colors. When it gets exposed to UV rays, it splits up into back to NO. But this time, the oxygen that we get, this oxygen item, is a highly reactive oxygen atom. Now this, what it does, it attacks. The problem with this is this oxygen attacks the membrane of living cells. This nitrous oxide, the nitrous dioxide that you got in the atmosphere, is partially responsible for smog. You would have seen in northern part of India that we face this a lot in the winter time. Then its brownish color makes smog visible. It also reacts with atmospheric water to form, that's the worst part, we get nitric oxide, the another unfavorable element from this. When it reacts with, I'll write like this, we got this one, then we add plus H2O, we get HNO3, which is nothing but nitric acid. This dilutes the rain, and in turn what we get out of it is called as, when it trickles down on the planet Earth, it comes in the form of acid rain. So if you see this, as a part of combustion from fuel to air, one of the worst part we would get is nitrous oxide and nitrous dioxides. Nitrous oxide will react with oxygen and give us nitrous dioxide, which will get affected by UV rays, will give us nitrous oxide back out, and the oxygen atom that we get is highly effective, highly reactive, and it will react with the cells of the living membrane, living cells. Then the nitrous oxide will also react with water present in the atmosphere. It will form nitric oxide and will dilute the pure rain that we have, and the result of it is we get nitric acid, which once falls, now has changed the normal rain, the beautiful rain for us, into acid rain. Following the next part, we look at carbon monoxide. This is one of the elements which results from incomplete combustion of hydrocarbons due to lack of oxygen. So instead of we getting carbon dioxide, we are getting carbon monoxide. The worst part is it is highly poisonous to human beings. What it does, it reacts. Once the carbon monoxide that you inhale reaches the blood cells, it will fix itself to the hemoglobin in the place of oxygen, and will diminish your oxygen carrying capacity of your lungs. Symptoms of it, you will suffer dizziness, and you will get, if you have the higher dosage of it, it may lead to certain death. Now you may be wondering, okay, if we are inhaling it, there should be some system in our body that would throw this element out or convert it into a usable form. But carbon monoxide that enters into the body binds very, very strongly to hemoglobin than oxygen, and these bonds are so strong that the normal body functions cannot break them. So the people who are intoxicated by carbon monoxide, they have to be treated in pressurized chambers where the pressure would make it easier to break the carbon monoxide and hemoglobin bonds. Naturally, it will not happen. So you have to subject the people into a very specific environment. Coming to the third one, unburned hydrocarbons may be harmful to the living beings. Some of these may be direct poisons and can be carcinogenic, may possess carcinogenic elements such as react with benzene. These are also responsible, unburned hydrocarbons are also responsible for smog. And the worst part is the sun's ultraviolet radiations, when they interact with hydrocarbons and nitric oxide NO in the atmosphere to form ozone. It will form ozone and other products. Now this ozone is a molecule formed with 3 oxygen atoms. I hope you are aware of it. We have O3 is our oxygen. It's very colorless, but it's very, very dangerous. So it's very good that it's on the upper atmosphere, not nearer to us. And it's actually very poisonous, and because it attacks the membranes of the living cells. This ozone, if we are exposed to on the surface, causes the membranes to age prematurely and die. Say the toddlers, the old people and the asthmatics suffer greatly from the exposure of the high ozone concentration. Finally, talking about other pollutants, in this, one of the major contributor we will get is hydrogen sulfides. With oxygen will release and give us a HS. We'll have multiple variants of SOx. In that SOx, the major contribution is taken care by, sorry, it's not taken care, but yeah, we get at the end is sulfur dioxide. So when this reacts with air, it gives us sulfur trioxide, which then reacts with water in the atmosphere and will give you your lovely deathful material called sulfuric acid. This is also one of the major components of acid rain. So let's summarize for today's lecture. So we have seen the reasons, one of the major reasons for pivoting is air pollution. Definitely this air pollution and the carbon monoxide elements are the ones, are the major contributors towards the term we are very familiar with by now. Global warming. So we got fuel and a hydrocarbon fuel which was burned in the presence of air. We will get heat and other combustion products. We were hoping that we'll get water and carbon dioxide as idle, but we get nitrogen oxides, carbon monoxide, unburned hydrocarbons and other pollutants, of which nitric oxides will occur in 3 forms. We'll have nitric oxide, nitric dioxide and nitrous oxide, which then reacts with oxygen in the atmosphere to give nitrogen dioxide, which when exposed to UV rays will give you nitrous oxide and highly reactive oxygen atom. This one attacks the membranes of the living cells and causes them to die prematurely. NO2 is also responsible partially for smog, and once exposed to water, it reacts with water and will give us nitric oxide, which will then result in acid rain. Similar phenomena we also observe with sulfur dioxide, which reacts with air and then water to give sulfuric acid, again resulting in acid rain. Carbon monoxide is highly poisonous to us. It attacks our breathing mechanism directly because it does not allow the blood or hemoglobin in the blood to carry the oxygen to its maximum capacity. It's not easy to break very easily, resulting in dizziness of the person, eventually death if not rectified. And unburned hydrocarbons may not be very harmful, but few are, and those carries carcinogenic elements which will again not good for the living organisms. So that's it for the lecture. In the next lecture we will begin with historical developments of electric and hybrid vehicles. Thank you.